Okay, let's get started. Thank you, everyone, for coming to this session about Micronaut. Before I start, I have one question for you. How many of you know a little bit about Micronaut? Okay, and how many of you have tried just play a little bit with Micronaut? Okay, cool. So in this talk, I'm going to show you what is Micronaut, and I'm going to show you all the things that you can do in something like 40 minutes. But before going into any details, let me introduce myself very quickly. I'm Iván López, on Twitter. I'm from Madrid, from Spain, and I work at Object Computing. OCI is the company that is behind developing both Micronaut and Grails frameworks. I'm a member of the development team. I also run our local Groovy user group in Madrid, and I used to organize Gridge for the last 7 editions. Gridge was a Groovy focus conference in Madrid. And for this last year, there is a new organizing team. They moved to a JVM conference. It was 2 months ago. I have here 3 t-shirts, so you can pick them after the talk. If you are interested in coming to Madrid for a JVM conference, take a look at the Gridge website. And I'm also a regular speaker at different conferences. And that's all I'm going to talk. So what I'm going to do is I'm going to try to explain what's Micronaut in something like 2 slides, and then I'm going to show you actual code. Micronaut is a framework for creating microservices for the JVM. It was created from scratch with microservices in mind for the same people that created and maintained Grails for more than 10 years. Its creator is Graham Roche. And if you know or if you don't know about Grails, Grails 3 is built on top of Spring Boot. So we've been using Spring for a lot of time, and in all those more than 10 years, we've learned a lot of things about how to do and maintain and evolve frameworks. So with that in mind, we created Micronaut with that. It's ultra lightweight, it's reactive, it's based on Netty, and one of the key features, and you can use the main 3 languages of the JVM to write your applications in Java, Groovy, and Kotlin. And one of the key features is this ahead-of-time compilation. Basically, annotation-based frameworks like Spring, what they do is that when you start your application, the framework needs to read all your bytecode or your classes, because when you do a dependency injection or when you put a component and service, whatever, the framework needs to know that and needs to really understand how your application works, right? So Spring does that at runtime, meaning that when you have a real-world application, not a hello world, it takes time to read more and more and more beans, and the framework needs to cache all that information in memory, so it takes more and more and more RAM. So what Micronaut does is pretty much the same, but it does at compile time. So when you compile your Micronaut application, all the meta information needed is already compiled there, creating some kind of companion classes. So when you start a Micronaut application, the framework doesn't need to do pretty much anything because everything is there. That means that there is no reflection, there is no runtime proxies, there is no dynamic class loading, nothing at all, right? Because everything was pre-computed ahead of time. And we use, as I said, Grails is built on top of Spring. We've been using that for a lot of years, so we wanted to have a really easy way for Grails and Spring developers to try Micronaut and to build applications with Micronaut. So we use the same dependency injection because we love that. We know that it works. It's really simple to create application with that, and we've been using that for a lot of time. Micronaut also provides a powerful HTTP server and a client that, again, generates all your HTTP client code at compilation time. We will see how it works at the demo. And we like to use this natively cloud-native thing because when you create a framework for microservices in 2018, you need to provide a lot of things out of the box for the developers, right? You don't need to worry about externalized configuration. Do you know about these 12-factor apps, right? So externalized configuration, distributed tracing, service discovery, HTTP client, fallback, retries, all those kind of stuff, integration with a lot of third parties. Micronaut provides a lot of them. I should mention that, if you don't know, it's open source. It was released less than a year ago, and 1.0 was released in October 2018, so something like 6 months ago. We have had a lot of feedback and comments from the community. A lot of people are sending pull requests. A lot of features are sent for the community. So we are really happy with all the feedback. And with all of this, you can have that your Micronaut applications start really, really fast because everything I said. The memory consumption is really slow because the framework doesn't need to cache a lot of information in memory. And it fits really, really well with serverless approach, in which you have, for example, if you deploy to AWS Lambda, you need to start up fast, do something, and stop, right? And if your application takes too much time to start or takes too much memory, you are going to pay more money, right? With Micronaut, you don't have that approach. And another thing that we wanted to achieve is that how you test your applications. And I'm going to show you how to do that later. And of course, Micronaut supports GraalVM because it fits really, really well because there is no reflection at all. So basically, that was my last slide. So I'm going to sit down, and I'm going to show you something like Micronaut in action. So if you want to use, can you see the font size? If you want to use, start using Micronaut, we provide a CLI to some kind of bootstrap, generate a skeleton for your application. It's not mandatory to use it. You can use anything you want. The easiest way to install Micronaut is using SDK man. So you say SDK install Micronaut, and it will download and install the latest version, 1.1.1, which was released 2 days ago. And then we provide an interactive console with auto-completion and a lot of things, and I want to show you here only 2 commands. The first one is list profiles, and these are profiles, so some kind of parent-level profiles that you can use to generate these different kinds of applications. So as you can see, we have a profile for creating CLI applications, another one for deploying code to AWS Lambda, to AWS, or a specific file for Alexa, gRPC application, Kafka, RabbitMQ, and the service one, which is pretty much the default one. So I'm going to show you now profile info service. And you can see here, these are all the features that the framework provides for you out of the box. You have a lot of commands, so once you have created an application, you can say create controller or create bean or whatever. And these are the features, the auto-configuration that we provide. So if you want to use discovery with Consul or Eureka, Flywave for your database migrations, the Graal support, GraphQL, Hibernate with Gorm or JPA, different data sources pool, Kafka, management endpoints, Micrometer with different backend implementations, the Mongo Reactive driver, Neo4j, the Bolt driver, Hickstrix, Archaeus, different Netflix integrations, the Reactive driver for Postgres, RabbitMQ, security, Swagger. So the only thing you need to do if you want to use any of these features is just use that name when you bootstrap your application. So what I'm going to do is I'm going to create an application. Let's call encrypt service. And the only feature I'm going to pass is Spock. So by default, Micronaut will create a Java project built with Gradle. If you want to use Kotlin or Groovy, you just need to pass that language. And if you want to use Maven, you can also use it. And as it is Java, by default, it will use JUnit 5. But I do prefer to use Spock. For me, it's way too better than JUnit. So let's load the project in our IDE. And let's see what we can do in the last 40 minutes. So I'm going to create a controller, encrypt controller. And of course, it's a controller. I'm going to expose the root URI. And what I can do is create a get endpoint, encrypt text. And it's public, my message, encrypt. And this is the text that we want to some kind of encrypt, right? And here, I'm not returning a string because in Java, we work with POJOs and we want them to be serialized, right? So when we return a POJO on a controller, Micronaut will serialize automatically to JSON using JSON under the hood. So let's create this class, get the text, and we need an empty constructor, we need another one, and we need getters and setters. So if you use Lombok, you can get rid of all of these. If you use Kotlin, you can also get rid of all of these. And if you use Groovy, you can. But as I'm using plain Java, I need to write all these things. And as I don't have too much time here for writing a real encryption service, what I'm going to do is create this kind of encryption, right? I'm going to just reverse the string. This is going to be my text encrypted. So return new message, my message, encrypted, right? So that's all. So now I have built the backend, right? This is my HTTP server. And what I'm going to do now is I'm going to create the HTTP client that I'm going to use for the tests. So I'm going to create a new class, encrypt client. It's an interface. And I'm going to use the @client annotation, mapping the same URI as I used in the backend. And here, the only thing I need to do is use the same signature with the same annotations. And what Micronaut is going to do, it's going to compile and create all these companion classes to implement this encrypt client for you at compilation time. Let me fix the typo, encrypt client, right? And now that we have this, what I'm going to do is I'm going to write a new test for this. So encrypt controller spec. It's an SPOC test, so I need to extend from a specification, and I'm going to annotate it with a Micronaut test. And what this annotation is going to do, this annotation adds 2 extensions, or an extension for both JUnit 5 and SPOC. You can use any of them. And this annotation is going to inject the embedded HTTP server. It's going to take care of all the injections and to start and stop the server and application contents and everything for you. So with that annotation, what I can do is I can say @inject encrypt client. No, encrypt client. And here I can actually now write my test. Test encrypt controller. And the test is pretty simple. I only expect that when I call with, I don't know, hello Devox UK, remember that this returns Apoyo, so I need to get the text. I expect that this will be something like this, if I know how to write it. So let's run it. It's compiling everything for the first time. It's generating all the classes it needs. It failed because I don't know how to write this, okay? So let me fix this. I need that B here, right? Okay, now the test pass, okay? This is why you need to write test, to make sure that everything works. And as you can see here, the test took something like 600 milliseconds. And this is not a unit test. We are not mocking anything. This is a real full end-to-end integration test. And as I know that you don't believe me, and you shouldn't, what I'm going to do, I'm going to duplicate the test, and I'm going to modify here my logback configuration to define, to set the trace level for the HTTP client so we can see all the traffic under the hood. So I'm running both tests again. The first one took, again, something around 600 milliseconds. The second one took only 12 milliseconds. And we can see the output. We send a GET request, encrypt hello Devox UK, to this server. By default, Micronaut will start on port 8080, but on tests, it uses a random port, some port that is available. Application JSON, this is the response, content type, and we can see here the response body serialized to JSON, right? And the first test took more time because pretty much it's bootstrapping the JVM and doing all the class loading and everything like that. But once you have done that, you can see that the second one only took 12 milliseconds to run a full end-to-end integration test. So with this, I'm not saying, let me delete this. I'm not saying that we should not write unit tests. Unit tests are useful, but sometimes we write unit tests because it's too much pain to wait 25 seconds until our application starts to have real integration tests. And sometimes we shouldn't write unit tests because it's easier to basically start the application and test the real code instead of mocking pretty much everything, right? So now with Micronaut, you have 2 options. You can still write unit tests, but in other cases, you don't need to write unit tests. You can write full end-to-end integration tests because they run really, really fast. Okay, what else? So we have our service, and here I'm returning Apoyo. Yep?
Currently, there is a duplication between encrypt client and encrypt controller. Is there a way so they share something?
Yeah, hold that, because I will answer that at the end of the talk. I'm going to evolve in the code, so yeah. We will show how to do that. So here I'm returning Apoyo, and as I said before, that Micronaut is built on top of Netty. So if you know a little bit about Netty, you know that Netty has this event loop, and the key is that you should not block the event loop, never, right? So Micronaut is pretty smart to know that if you are returning a POJO, this code is blocking, so it will move automatically this code to a different event pool, right? To do not block Netty event loop. But if you want to make your code reactive and non-blocking, the only thing you need to do is return some reactive type. So I'm using here RxJava single. You can use anything that implements the reactive stream, so RxJava, ACA, or reactive project reactor. Anything that implement that should work. And the only thing I'm going to do here is just returning a single with my message. As I have modified this signature, I need to modify again the same signature for my client. And then my test, you know that IntelliJ here is complaining because I'm not returning a POJO anymore. So the first, now. So the simplest way to fix this is doing here a blocking get, which basically it's subscribing to that single to get the result, right? It's fine to block the code in a test. So the test now still pass 600 milliseconds. So we've converted our blocking implementation to a reactive one, right? And the next thing I want to show you is that here in my controller, I have my business logic, and you don't put your business logic on controllers. Controllers are for another thing, for talking HTTP. So now I'm going to create a new class, encryption service. I'm going to annotate with with a singleton. And now I put here all my business logic that I will refactor in the future to doing a properly encryption thing. And the only thing I need to do in my controller is just inject my encryption service. I'm doing constructor injection, encrypt text. So I'm running the test again. It should pass. And as you can see, it's pretty much, or it's always the same as you already know in a Spring. You define your dependency, and you can do a constructor injection. You can also use a fill injection if you annotate with an inject. For a test, it's fine to use a fill injection. But for production code, please don't do that. Use always constructor injection, because this allows you to define all your dependency final, so no one is going to be able to modify it. And if you don't want to use this, you can also use setter injection. But this is the recommended approach, right? So now we have our business logic where it belongs, in a service. We have our microservice. And what happens when we have microservices is that we need to find a way, or we need to do something to discover the microservices, right? Because we don't want to hardcode URLs and ports. So what I'm going to do now is I'm going to add, let me close this. I'm going to add support for discovery service with console. So I'm going to modify the build.gradle to add the dependency for console, and I'm going to modify my configuration. And basically, I'm enabling console registration, and I'm saying that console is running on port localhost 8500 by default. If you define these variables, those variables will be used when you deploy to another real-world environment. And the last thing I'm going to do is define server port -1, because I want to start these microservices on a random port, because I want to have more than one instance. So let me run console using Docker. And let's run the application for the first time. So it took barely 2 seconds to start. It's running on this random port. Let's start another instance. It registers itself using the encrypt service on console. So I have one instance here, another one. So if we go to console UI, we can see that here we have the 2 instances, okay? Same name, different ports. So everything now it's up and running. We have these microservices. I'm going to leave it here. And I'm going to create another one, because when you have a microservice architecture, you don't want to expose all your microservices to the clients, right? You want to put something in between to basically ask some kind of a gateway. And in this gateway, you will control security, you will have retries, fallback, HTTP load balancing, all that kind of stuff. So I have here my microservices, in this case, this encrypt1, encrypt service. I have 2 instances. So I'm going to create this gateway to be able to expose this for my clients. So let's go back here. And I'm going to create a new application, gateway, and I'm going to pass here 2 features. Discovery console, which will add the same thing that I did manually, the dependency on the bit.gradle and the application YAML configuration. This feature will do that for you, so you don't need to know everything. You only need to use the right feature or check the documentation to modify your existing application. And the other one I'm going to add is tracing with thickening, that I will talk about it later. So we have our application. Let's open on our IDE. Okay, and now, what I'm going to do, I'm going to create another controller. This is going to be my entry point, my gateway controller. Again, a controller. And I want to expose this some kind of, using this API, API.version v1. This means that if you define in any place this variable, API version, that will be used. If not, by default, it will use v1, right? I'm not going to define it, so it will work with v1. And then I'm going to cheat a little bit because I don't want to write everything again. So I'm going to copy this here. And I also need to copy these 2 classes here, right? In a real-world project, what you are going to do is basically this. Probably you will put these 2 classes on a separate project, and you will have a Gradle or maybe multi-project build to share that small jar in between all your projects. But I don't have time for that, so I'm copying and pasting. But again, don't do that on production. And I'm going to modify. So in the other microservice, I use this client for testing. You don't need to create a specific client for testing. We provide some kind of low-level RX non-blocking client. But I did it because I want to use now this client for the real code. So instead of saying that this client is going to map the end URI, so the root URI, I'm going to say that this is a client for the encrypt service. And then I'm going to here again inject my encrypt client. And let's use it. Oh, come on. So another thing I forgot to mention is that the code, it's already available on my GitHub account. I will put the link later, so don't worry about the specifics of the code. You will have everything to play after the talk. I created small commits so you can see all the differences that I'm explaining now. So I have here everything. You can see, as I said, that by default we have here the discovery client dependency. And in my application.yaml I have the console configuration, so you don't need to worry. And now I think we can start my app. Okay, so this starts by default on port 8080. So let's go here and say localhost 8080, hello, Depbox UK, right? And you can see this is the raw data. This is my JSON encrypted, you know. And every time I reload the service or the browser, because remember that I have 2 instances of my backend, of my encryption service. So what Micronaut is doing, this HTTP client, it's doing a round-robin policy to call one service after the other, right, by default for you. But you cannot see it because the output is exactly the same, right? So again, you probably won't believe me. So what I'm going to do is I'm going to modify my encryption service to inject here final. This embedded server is the instance that all Micronaut application has. This embedded server, it was the same that we use on the tests. What I'm going to do here is say, I'm going to put the port in which the application is running. So let's start again 2 instances. The first one, 33249, and the other one, 54079. So now every time I reload, you can see, now you can probably see it better, that the request is sent doing a round-robin policy for you for free. If you don't want this kind of policy, load balancing policy, you can implement your own. You only need to write a Micronaut bin, replace the Micronaut, the one that Micronaut provides, and you can put there any policy that you want. By default, you have a very sensitive one. And now that we have this, what I'm going to show you, because we are talking about microservices, right? So this means that, and here I only have one, but you will have a lot of them, and they connect each other with the network, so they are going to fail, right? The network is going to fail, or any microservice is going to fail, it's going to be down. Something bad is going to happen. And we need to deal with that when we write our application, right? Because we don't want that, because of this microservices fail, that failure is going to propagate through all our architecture or our microservices. So we need to provide some kind of fallback. So what I'm going to do now, and with that I'm going to answer your question about how to share in the code and how to avoid to do that. This is my, no, I'm going to do that on the gateway. So I'm going to stop the gateway. And I'm going to implement a fallback in 3 steps. So the first one is that I'm going to here create this encrypt operations. I'm going to create this interface. And basically, I'm moving this out of my HTTP client. So this is the contract that I want to make sure that everyone implements, right? You should also put this class on this small jar that you will share among the projects. And in this project, I only extend from that, and I say that this is an HTTP client, right? Remember that Micronaut will implement this for you at compile time. The second thing I'm going to do is I'm going to make sure that everyone implement that contract. And as you saw, nothing happened. The only thing that happened here is that IntelliJ knows that I'm implemented the right interface, the right contract. And the last thing I'm going to do, I'm going to create a new class. Let's call it encrypt client fallback. The name is not important. The thing is that, come on, you need to annotate it with a fallback. And here, again, I'm going to implement my operations. And in this method, you are going to return this fallback, right? So you need to return the same signature because it's a fallback for that operation. So I'm going to return a single new my message, and I'm going to say this is the fallback, right? I'm going to restart my app. And remember that these 2 microservices are still up and running, so everything should work like before. I reload, I still have my round robin, but now I'm going to stop both of them and then reload the page, and you can see that instantaneously I have the fallback. This means that I don't have 500 error, 502, 404, nothing like that. It's a 200. It's an error. I mean, sorry. It's an OK request, but it returns some kind of fallback text or option or response. You can use this. Imagine that you have this, for example, e-commerce site, and the user is looking for this product, and the user wants to buy the product, and you have here this kind of recommendation service that you say, the users that bought this also were interested in these things, right? And these recommendations are probably coming from, I don't know, a recommendation service or microservices. It returns a list of products that you recommend. And if this recommendation microservices fails, you don't want to basically, or the other way, you want that your user will be able to still buy your product, right? So instead of failing, you will return some kind of fallback. And for that example could be just an empty list. And then the UI won't put the recommendations, but the user will be able to buy your product and give their money, right? So this is the fallback. And of course, when you start your microservices again, everything, right? The first one, 2542, and the second one, and on another port, right? They are available again without doing anything, right? And we also have another fancy annotation. So you have this at retriable, and with this, you can define a retry policy, because sometimes you don't want to return the fallback just when it fails for the first time. You may, for example, say, okay, I want to retry 3-4 times, and I want to delay 500 milliseconds between retries, because depending on your use case, maybe it's better to just wait a little bit, add a small delay there, 500 millisecond retry again, and get the real answer instead of returning the fallback. You can configure anything you want here. We have also this circuit breaker annotation. If you know about Netflix histories, this is the same. It's not as powerful as histories, but it provides a lot of it implements this circuit breaking pattern, and it provides a lot of nice features about circuit breaker. You can define again the attempts, the delays, the max delays overall, a lot of things. And using these annotations, they follow the same approach as everything in Micronaut, implemented at compile time, without runtime proxies, without anything like that. So if you don't have a really complex use case, it's easier to use this annotation that it's inside the framework than using, for example, histories and bring another dependency to your application. Okay, so we have fallback, and the next thing I'm going to show you is about tracing, because when you have a lot of microservices, imagine you send a request to this gateway, and that request is going to touch 5, 7, 10 different microservices. And when you want to take a look what happened, you need to some kind of have a trace, a path through all those microservices, right? So you can do that using distributed tracing. Micronaut supports out of the box Zipkin and Jagger. I'm going to show you Zipkin. But it's the same. So the same annotation applies for both things. The only you need to do is put the right dependencies. So in my gateway, do you remember that I also added that Zipkin feature when I created the application? That means that here I have the Zipkin dependencies, and I have already the configuration. The only thing I'm going to change is this. This sample probability means that you probably don't want on production send 100% of your requests to Zipkin, right? You only want to send a small sample, something like 10%, 25%, whatever you want. But here for the demo, I'm going to send 100% because I don't want to send 50 requests to have one on Zipkin, right? So in this application, let me start Zipkin again on Docker. This takes something like 5 seconds. 4, so it's up and running. And now here again, I'm going to modify my encryption service with the same things that the feeder added. So I'm going to add the dependency. Woo. Okay. I'm going to add the dependencies, and I'm going to modify here my configuration. Where is it? Here, right? So just adding the. Let's stop this. 2 instances. I'm going to start. I only need one now, so I can close this. I have 1 instance, and my gateway is also up and running. So what I'm going to do, I'm going to open here Zipkin UI, and I'm going to send a new request. Hello, Zipkin, right? It works. I mean, nothing changed from here, but as you can see. We have here now the 2 instances, and we can try to find the traces, and I think this is one. So you can see the gateway get hello Zipkin. We can show IDs. These span or traces are some kind of the IDs for this whole kind of path, and we have also our encrypt service, right? So you can see here pretty much everything. And the only thing I did was adding the dependencies. And Micronaut will do its best effort to try to figure out everything and trace everything for you. But you can customize this even better, or even more. So if you want to, so you can say, for example, here, new span, you can annotate this. And with this annotation, what you are going to do what you are saying to Micronaut is, every time this endpoint is hit, open a new span, which is a new trace, right? And you can also say, and here, please store this value, let's call it plain text, as a header on the trace, because I want to make sure that if something wrong happens, I have enough information on my logs to be able to trace this. So let's restart my gateway, And now I'm going to send another request with span tag. And if we go back here, let's try to find less than a minute ago, probably it's this one. And we can see, I think it's here or here. Yeah, you can see here my span tag, my plain text already saved inside Zipkin, right? So you can use this to put, I don't know, your user ID or some kind of information that you will be able to use later if you want to trace this or to put in some kind of dashboard or whatever thing you use. Right? Okay. So, and now what I'm going to show you is I'm going to talk a little bit about GraalVM. How many of you knows about GraalVM? Okay, it's been a lot of hype around Graal. So they announced the first some kind of stable release just yesterday. So I'm not going to use that. I'm going to use the previous release candidate. So GraalVM is a new polyglot virtual machine from Oracle that uses another Git just-in-time compiler written in Java, right? And you can just replace your Oracle JDK or your Open JDK that you are using now with that VM. But inside this GraalVM project, there is another tool called Substrate VM, which is another thing that allows you or allows us to convert our Java applications to native images, right? To binaries that run like a native image, a native binary on your OS. At this time, they support only Mac and Linux. In the release that they released yesterday, I think they have some kind of beta access for Windows, but it's not. I think it's not stable there. So what I'm going to do, so before that, if you want to create a Micronaut application with Graal support, the only thing you need to do, create app, foo, features, Graal native image. This is the feature you need to pass. And this feature will add 3 or actually 4 things to your project. So instead of using this project, what I'm going to do is I'm going to manually add these features or these things to my encryption service because this is some kind of an application that does something, right? So one thing that happens when you create this native image is that they take a lot of RAM, they need a lot of RAM, and they need a lot of time to create that image. Something like 3-4 minutes, depending on your laptop, on your application, right? So what I'm going to do is I'm going to do all the modifications really fast. I'm going to start creating the native image, and while the image is being created, I'm going to go back and explain everything, right? So don't worry if you miss something in the next 2-3 minutes, because I will go back just after launch the native image creation to explain everything, okay? So I need to add the dependencies. I need to create here a directory, metainf, native image, encrypt service, and I'm going to create here a new file called native image.properties, and this is the content. And the last thing I'm going to do is I'm going to annotate it with that introspected. So I think we are good. And now, so I'm using here Java OpenJDK 8. So to use Graal, you need to use that JVM. And the easiest way to switch between JDKs is using SDK Manager. If I know how to do this, SDK. Oh. So you can see here all the different virtual machines that I have. So I'm going to SDK use, Java, and this one. And as you can see, now I'm using the release candidate 16. That was the latest stable before yesterday. So I'm going to create Gradle W assemble. I'm going to create my fat jar. It's the same fat jar that you launch with Java -jar and the name of the jar. And I'm going to use that fat jar to create my native image. So as I'm using this GraalVM, I have a new command which it's called native image, and I only need to do no server and class path, and this is the jar that I want to convert to be a native image. So let's take a look here. I'm using now something like 6.3.4 gigabytes of RAM. And during this process, it's going to take 6-7 gigabytes of RAM. So it's going to go to 13 or so. So this graph will go up to around 80% of all my memory. And it also takes a lot of CPU. So now it's starting to do something. But at the end of the process, my 4 cores are going to go to up to 100% for something like 30 seconds. So now it's this. I have something like 3 minutes until this process ends. So I'm going to explain what I did. The first thing is adding the dependencies again. We need this substrate VM. And we need the Micronaut Graal integration. This dependency is on annotation processor scope. This means that the code in that project is running when you compile your application. And what this has, or this project provides, is a type element visitor, which is a thing that we use basically to hook into the compiler to do stuff while you compile your application. And what this Graal type element visitor does is creating all the meta information that your application needs, that Graal needs to know about your application to be able to create that native image. The next thing I did was creating this file, native image, inside my metainf native image directory and the name of my app or my package. I created this file. Starting in release 14, I think it was 14, release candidate 14 or 15, the Graal team introduced, yeah, you can see it. The Graal team introduced a new feature, which is that you can embed these files inside your jars to tell Graal how to create the native images. So now Micronaut, started with 1.1.0, includes a lot of these files inside Micronaut jars. So when you use any Micronaut dependency, everything is already pre-configured for you, so you don't need to worry about all Micronaut dependencies, how to tell Graal they should work. We do care about that, so you only just need to do that. But here, yeah, you can see what I was talking about now. All my 4 cores up to 100%. I think it will finish in something like a minute. So the only thing you need to do for your application is define, okay, my resources are my lockback configuration and my application YAML. These are my static resources. This is the name of the binary it's going to create. You can see it here. What is it? Yeah. This is the binary. It's going to finish now. Right? So you can see now it's pretty much finishing. Yeah, writing the image. Okay, so now, again, I have all my memory back. Right? And all my cores. So and it took something like a little bit less than 3 minutes to create that native image. So this is the name, and this is the entry point, the main class of my application, because what Graal does is, starting from my entry point, it's going to analyze everything and get all the reachable code and grab that while creating the native image. And the last thing I did was annotated my POJO with an introspected. With this annotation, which also was introduced in Micronaut 1.1, we generate some bin meta information at compile time. And that meta information is used also for Graal, and basically to avoid using reflection to access that. So with that API that we provide, you can instantiate, set properties, read properties, do a lot of things with these Java beans without using reflection at all, right? And this is useful for creating the native image because you don't need to worry again about reflection. And the last thing that the profile, the feature native image does that I'm not going to put it here, is it creates a custom Dockerfile image. So this is the one that we provide with Micronaut, using this Alpine small image to run your Java application. But if you use that feature, it creates another Dockerfile to be able to create the native image inside Docker, because maybe you don't want to have to install GraalVM on your laptop, or you are using Windows, so you can't do that. So you can use Docker to build the native image, and then it's a Docker multi-stage build. So in the next stage, it is a small Alpine JClib binary or Docker image to just run that Linux native image. So now, what I can do, you can see here that all my whole encryption service now is 62 megabytes. This, maybe you may think that it's too much, but you don't need the JVM to run this. It's self-containing. The only thing you need to do, basically, it's running. And you can see, bam, it started in something like 44 milliseconds, so it's instantaneous. If you blink, you are going to miss it, right? And this is the same application I showed you before, so it's running on this port, 44662. It registered itself in console. So if I say here, I send a request and I say GraalVM and Micronaut 44662, which is my native application. So this is the one that is answering that request. And if I go back to Zipkin and I try to find it, probably I think maybe it's this one. We can see here GraalVM and Micronaut, right? So this is the request that I sent to my native image, right? And you can see everything here as before. So 6 minutes, perfect. So let's go back here. So as a summary, with Micronaut you can create microservices using Java, Groovy, and Kotlin. So for Java and Kotlin, we use annotation processors to do all this kind of stuff and generate all the meta information and everything the framework needs at compile time. For Groovy, we use AST transformations. Micronaut is natively cloud native. I showed you in something like 40 minutes how to use distributed tracing, service discovery with console, externalized configuration. I didn't show you actually, but if you define this API.version, it will work. You've seen also HTTP client, the fallback, the retry, a lot of things. And you have seen that we have integration for a lot of things, and we implement more and more in every release. We use the same dependency injection that we are used to. If you are Grails or Spring developers, it's the same model that you know and you probably love. So you don't need to think too much, or you won't have a hard time to start using Micronaut, because it's exactly the same as you already know. Micronaut is based on this ahead-of-time compilation, which pre-computes everything ahead of time, right, while you compile your code. So remember, there is no runtime proxies, no reflection, nothing like that. And another advantage of that is that if you have worked with Spring, you know that when you have a stack trace, you will see this very big stack trace with a lot of const, sun, misc, proxy, whatever, right? Because there are a lot of runtime proxies there, right? With Micronaut, you won't see that because there are no runtime proxies, and your stack traces will be smaller. They will be really easy to read. With everything, you have the really fast startup. You saw that when I was running the applications inside my IDE, it took something like 1.5 seconds, 2 seconds to run them. This laptop has almost 3 years, so if you have a new fancy laptop, it will start around 1 second. And it doesn't really matter if you have a hello world application or a real world application with hundreds of beans, because everything is pre-computed at compile time. So the startup time will be pretty much the same, because the framework doesn't need to do anything different when you have a lot of code or nothing, because everything is done at compile time. So at the end, the developers are happy because they have a new tool, and they can focus on solving the problems instead of fighting the tools. So a few links. The first one is our webpage, micronaut.io. The second one is the documentation. In there is the Micronaut core documentation, and also there are links for a lot of different modules. So pretty much all those features that I show you are lives in different projects, so they have its own documentation. They are linked from the main one, but the details are in the other repos. The GitHub project, please put that on a star. And that guides.micronaut.io, that's really important. So if you want to learn how to do something with Micronaut in something like 30 minutes, there are a lot of guides. So the guides has some explanations and a repo that works with actual code to solve a problem. So if you want to learn how to use security with JWT, you have a guide. How to use Zipkin, how to use Jagger, JPA, GORM, the HTTP client, creating your first Graal application. There are something like 60, 70 guides now. Pretty much all of them are written in the 3 languages. We have a few of them that are written only in Java, and the Groovy specific ones, for example, when we use GORM, are only written in Groovy. And the last one, if you know about Slack, Gitter is another option. So if you have some questions, feedback, anything, go to that Gitter room. The development team we are there. So if you have any questions, just come and talk whatever you want. Please do not forget to rate me using the application. And that's all. This is my contact information. The code and the slides are already online on my GitHub repo. I will tweet about it. And if you have something like 30 seconds, please go to that URL, bit.ly/devoxuk-micronaut. It's the same URL in this QR code. It's an anonymous Google form with only 4 questions to give me a feedback about the talk. This is only for me. It will take you only something like 30 seconds. And I said it's anonymous. You can say anything you want. I won't be offended. If you like the talk, please let me know. If you didn't like the talk, also let me know. And I think that was all. Maybe we have 1 minute for questions. Please remember to grab some T-shirts, some stickers. And that was all. Thank you very much. Any questions?
So if you're compiling everything in advance, if you're using build features to maybe customize your application for a different environment, putting in a mock for some services that are in that test environment, do you just do multiple builds? Are there different Gradle profiles that you use to create a different version of your Java?
No, because when you define when I define this API.version, that's, so the real value is not there until you actually run the application. So what we create is some kind of placeholder for that value. So you don't need to have different profiles or different anything for it. And
Different service implementation with maybe Spring wire and a different bean.
you can replace beans with another. So for example, for tests, one thing we do is basically replace Micronaut core beans with implementation that we need for testing something. So you don't have that problem, I think. Maybe I'm not answering the right question.
Well, if you've got a prod environment and a test environment where you're just testing locally, then yeah, I think that works. But if you've got different grades in between, so you've got maybe a UAT environment where you've got a security service where you want it to always return that somebody's authorized, then so you've got a different service implementation. I think it would normally be maybe a different bean you would wire in, profile you do for the build. Seems like that might be slightly harder to do in Micronaut unless there's any other.
I'm not sure. We can talk later. I will be here for the rest of the day, so we can talk. Yeah. Thank you.